Hey everybody, in this video we're going to practice finding limits graphically. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. So what we're given here is just a graph. No equation to plot, just a graph. And so what we want to do is we want to find limits involving this graph. Now the other thing that we're also going to be finding is values of the function at certain points. So for number 1, it asks what is the value of f of 0. So at 0, when x is 0, the function has a value of 0. So we're going to say that f of 0 equals 0. Now with 2 and 3, that's different because now we're finding the limit as x gets close to 0, but not at 0. With number 2, we want to find what are the values as x approaches 0 from the positive side. So looking at the graph, we're asking as we get close to 0 from this side, what does it get close to? Now since it's a horizontal line, all the values along here don't change. They stay 1. So that is our limit as we approach 0 from the positive side. For number 3, here we're finding the limit as it approaches 0 from the negative side. So that means as we get closer to 0 from the left, what do the y values approach? And for this side, they approach -1. Now what's important about number 4 is that it says what is the limit as x approaches 0. There's no plus, there's no minus. And this is important because you see this very often when we do graphic limits, is that these two, the left and the right hand limits, have to be the same. The function has to be approaching the same spot from both sides. And in this case, it's not. So actually, it's not equal to anything. This limit does not exist. All right. Now with number 5 and number 6, oftentimes when we see limits, we also see that some textbooks often throw out some transformation ideas involved with limits, and they are very intuitive. Here, we want to find the limit of f of x plus 1. Well, what does the plus 1 going to do to f of x? Well, it's going to shift the entire graph up. It's going to move all the values up 1. So we're asking, what is the limit as x approaches 0 from the negative side? Well, looking up here, it would have been -1. But by shifting this graph up, that's what this plus 1 does. Shifts up 1 unit. What that means is that instead of -1, we add 1 to that, and so we get a limit of 0 here. Looking at number 6, this 3 that's being multiplied is that this graph is vertically stretched by 3, which means that all the values get multiplied by 3. So they're going to be 3 times out this, 3 times above the x-axis and 3 times below the x-axis of where they would normally be. So normally we would approach 0 from the positive side and we would approach 1. But when it's 3 times as much, that means the limit is going to equal 3. And most of the time when we have transformations, at least transformations that are vertical, you just do whatever's you see. You add 1 to the limit, you multiply the limit by 3. If it's horizontal transformations, that's going to affect the graph a little bit differently. So looking at the next page, we have this function. We have this segment, this point, this segment, and then this half of a parabola. So first we want f of -2, and that's this point. And so that gives us a y value of 2. And we want f of +2, and that's this point right here. And this has a value that's halfway between 2 and 4. And so since the y-axis is labeled only with even numbers, we can assume that this is 3. So looking down at number 9, we want to find the limit as x approaches -2 from the positive side. So here is -2. So we want to approach it from the positive side. So as we get closer and closer to -2, we get closer and closer to 4. Now number 10 asks, now we're approaching negative 2 from the negative side. So here's negative 2. So as we get closer to negative 2, we get closer and closer to this point. Now, even though that has an open circle here, still, we're getting closer and closer to it. So that means this is what we are approaching, this spot right here. And this spot has a value of 1. Looking at number 11, it asks, what is the limit as x approaches 2? Notice that it doesn't say positive or negative. So we're just looking here at 2. Now as we approach from the negative side, from the left, we approach 4. We'll mark that there. And then as we approach 2 from the positive side, we approach 3. Well, in order for the limit, we call it a two-sided limit, to exist, both of the sides have to be the same, but they don't. So in this case, this limit does not exist. Now, one-sided limits will almost always exist. And I'm going to show you an example right now of why they don't always exist. Here at number 12, we have negative 4 is approaching, we're approaching negative 4 from the negative side. So here's negative 4 right here. So we're going to approach it over here. Well, there's a problem. This function doesn't exist over here, which means we don't know where to follow. And so because we don't have a function to follow, we don't know what it's approaching. So that means this limit does not exist also. Now, rarely you'll be asked to find a one-sided limit that doesn't exist. But I show this to you because oftentimes most books give you the sense that one-sided limits always exist. And here's an example where they don't always exist. Now, looking at number 13, here we want to find the limit as x approaches positive 4 from the negative side. So looking at our graph, here's positive 4. So as we approach it from the negative, from the left, here we're approaching this spot right here. And that is, well, this entire graph is scaled by factors of 2, so that means we can assume that this has a value of negative 1. So as we get closer and closer to 4 on the x-axis, we get closer and closer to negative 1 on the y-axis. So looking at our last graph, now this one involves vertical asymptotes, which means that oftentimes these limits involve infinity because the graph just keeps going, either keeps going up or down. So we're going to have positive and negative infinities involved. So at number 14, we have the limit as x approaches negative infinity. So as x goes to negative infinity, that means it's going to go off the edge of this graph forever. And what's it doing? Well, it's flattening out closer and closer to the x-axis. And so as it gets closer and closer to the x-axis, the y value is going to get closer and closer to 0. Now, some people may say, well, what if it does something beyond the edge of the graph that we don't see? It's bad form to show a graph and not show something important that's happening. So when you see behavior like that and the graph gets cut off, there's the common assumption that it's just going to keep doing what it's doing. It's just going to keep getting closer and closer to the x-axis. So as it does, the x value gets closer and closer to negative infinity, but the y value gets closer and closer to 0. Looking at number 15, x is approaching positive infinity. So now we're going to follow the graph this way, off the edge. And again, the graph is just going to get closer and closer to the x-axis. So the y value is going to get closer and closer to 0 as x gets closer and closer to infinity. That means it just keeps going up forever. So now, number 16, we look at as x approaches negative 1 from the positive side. So here's negative 1. So we're going to approach it from the positive side. And as we get closer and closer and closer to negative 1, the y value just keeps going up, 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 up. And the closer we get, the higher it is. And that means it's going to keep going up forever. So that means this limit is infinity. Now, some books will say that the limit does not exist, but oftentimes some books will accept infinity when they're talking about limits and asymptotes. So now 17 we say as x approaches -1 from the negative side. So here's -1 and we're approaching from this side. And as we get closer and closer to -1, the y value is just going to keep going down, down, down. So as x gets closer to -1, the y value of the function gets closer and closer to -infinity. So now with numbers 18 and 19, now we're looking as we approach +1. First, from the positive side. So as we approach +1 from the positive side, the y value is just going to be going up, 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 up. That means they're approaching infinity. As we approach 1 from the negative side, they're going to keep going down, down, down to -infinity. And so anytime you have a limit that involves infinity, if it's a y value, that means you're looking at some kind of vertical asymptote. If you have an x value and a limit where x is approaching infinity, then you're usually talking about some kind of horizontal asymptote of some kind. Hope this helped. If you liked the video, please give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the only way to understand something is to do it.